do my welcome. All right. So hello, everybody. I'd like to welcome you all to today's Green Living Seminar webinar, and this is the final presentation in this semester's series. And I would just like to note that this presentation is being recorded. So if you would like to watch this or any other Green Living Seminar presentations, feel free to peruse the MCLA Environmental Studies YouTube channel, or you can also find links to audio podcasts of prior Green Living Seminar series presentations. I'm Elena Traster in the MCLA Environmental Studies Department. This semester's Green Living Seminar has been organized around the theme of environmental pollution. Due to the spread of COVID-19, these lectures have transitioned to being online webinars. As always, they are free and open to the public. We expect today's presentation to last for about 45 minutes with an opportunity to ask questions, mostly at the end. Perhaps there will be an opportunity here or there during the presentation. I am generally keeping the chat box closed until we invite questions, and then I do invite you to add them there or wait for a pause and just speak your question. During the presentation, if everyone could please mute their microphones except for the presenter, because I can mute your microphone for you if I need to, but then I'm not sure if you'll be able to get back in. So better to do it yourself so that you can undo it. And then finally, announcing today's presenter. Today's talk is titled Acid Rain, How Science and Volunteerism Contributed to Addressing an Environmental Challenge. It's going to be given by Paul Godfrey, Emeritus Director of the UMASS Amherst Water Resources Research Center. And so just to sort of get around some technical difficulties, how we're doing this today is that I'm going to be sharing my screen with his slides. And so I've updated my profile with his picture so you can at least see what he looks like while he's talking. And I'm going to turn it over to him. So I'm going to mute myself here, and I'm going to turn off my screen, my video, and I'm going to share my screen. And then, Paul, you can feel free to take.
Thank you, Elena. I hope you all can hear me. Thank you for inviting me to talk to you today. I hope you're all well and safe. I can't say I hope you're enjoying all of this isolation that's going on. It's certainly presented a challenge to all of us. Today I'm going to be talking about acid rain, but really I'm going to be talking about what we did with acid rain back in the 80s, ancient history, sometime between the dinosaurs and IBM PCs, how that history lends itself well to the kinds of problems that face us at the present time. So, as Elena mentioned, I am the Director Emeritus of the Water Resources Center. I became acting director in 1981. And one of the purposes of the Water Resources Center is to solicit small research projects from qualified university and college professors and their students to solve problems in the area of water resources. This was my second year that I started on the acid rain thing. Acid rain had just come up as a major issue. A Swedish researcher had discovered that lakes he had been studying for some time were losing their fish, and he noticed that the pH of the lakes, and I'll talk a lot more about pH in a bit, the pH of the lakes had been going down, meaning they were becoming more acidic. He published his results, as we academics do, and it caused some alarm throughout the world, particularly for areas like the northeast of the United States, where our geology and our water quality is very similar to that of the Scandinavian countries. Notably, we have little ability to neutralize any acids in the water, and the pH will change fairly quickly. So there were some, very few, but some observations that fish that had been in lakes were disappearing or had disappeared, and the alarms went out. And typically what happens with alarms like that is that there are two sides quickly form, one side saying it's probably the end of the world, and the other side saying there's no problem at all. Does it sound familiar? Uh, but as acting director of the Water Resources Center at that time, it was my job to get some facts, to find the truth. And so as part of a research project, what we did was have research projects by researchers on our campus at UMass and other campuses throughout the state. And I solicited research, and one of the priorities, only one of them, there were probably 3 or 4 priorities, was on acid rain. I received 5 proposals on the subject, and I looked at them. I was impressed with all of them, and I thought, boy, these go together beautifully. One was on water quality, one was on the geological processes in the watershed, and so on. And I talked to the researchers and I said, you know, this would be a really powerful proposal if we put all of these together. And so I worked with them, and we did, in fact, do that. One large proposal, roughly with a budget of $1 million, and that's much too large for the tiny little research funding that I was administering. So we sought to get some much larger funding, and we presented this to EPA, who at the time was in charge of responding to acid rain research issues. And because of the large involvement that I had at the university with people at the university, the media at the university found out about this. The news that we were putting this proposal together and submitting it to EPA got into the press, and pretty soon we had some interest on the part of the various state politicians, notably Ted Kennedy. We also had Silvio Conti, who was in the House of Representatives from Berkshire County at the time, and Ed Markey, who's in the Senate right now, all of whom were very interested in supporting this legislation. And they actually Ted Kennedy managed to attach this to the appropriation bill for EPA. We suddenly thought we had $1 million. And for about a week, we thought that, and then we were told by EPA, no, there had been a procedural mistake, and it was put in the wrong budget, and they couldn't fund the project. So as a result, the project died before it got started. But because of that, I got working with several of the researchers, one of whom was Dr. Tom Zajac in the chemistry department, and he had just started to collect some rainfall from the roof of the science building at UMass and measure the pH, just out of curiosity. And I said, how about if we create a public report, an acid rain report, that we would release to the media, telling a lot of people what the acidity of their rainfall is. We won't make any judgments about whether it's a horrible thing or a good thing. We'll just report what it is and give it some categories like it's very acid, it's not very acid, and so on. And so I talked with the weathermen from all of the TV stations in the Springfield area and also in Boston. They all carried this acid rain report. Also the Boston Globe, the Springfield Republican, the Hampshire Gazette. I don't know if we had the Berkshire Eagle, but we might have, all carrying the acid rain report. And I talked with all of the weathermen who did this and the people in the newspapers who did it. But the report itself was just a simple box that had the pH and one of 4 categories of acidity that this was. Our acidity was typically 4.1. Naturally, we would expect the acidity of rainfall to be 5.6 if there's no pollution in it. 4.1 is pretty low in the pH scale. And this was carried, it kind of raised the awareness of people throughout the region. And as a result of that, I got a phone call from the library in the town of Amherst asking if I would come and give a talk. At the time, I was not a very experienced public speaker, and it made me a little bit nervous to think about this. And I didn't really feel like I was the most qualified person to talk about it, but in thinking about it, I couldn't really come up with someone who was more likely to have a broad view of what the acid rain problem was. So I dutifully sat down and started doing my homework, pulling together information, and at the time we were all using slides, and I was taking slides of various magazine pictures, research reports. I was asking friends in various state agencies and at university departments to help me out with the slides. I put together from that a presentation that I gave to the town. When I walked in, I expected to have maybe 10 or 20 people to listen to my project. Instead, it was a very large room holding probably 100 people or more, and it was packed, standing room only. I was very nervous, but I stood up there and gave my presentation. A week later, I got another phone call from, this time, the Arcadia Sanctuary in East Hampton, a smaller group, but equally interested. I gave the same presentation to them, and at one point, I want to show you this slide. Oh, can you change the slides, Elena? You can see some of the press that came out. I'm not reading my notes here very well to tell you when to change the slides. This is some of the press that came out as a result of our research project that was to look at Quabbin Reservoir, probably the most important water supply in the state of Massachusetts, serving all of metropolitan Boston and a few other places. And as you can see, we got $1 million. Change the slide again. And this is about our acid rain report. We did, we had these 13 outlets that we used, and we'll go to the next slide. Next slide. This is one of the slides that I showed at those two presentations. The one, whoop, back up, please. Thank you. One of the slides that I showed at that presentation in the town of Amherst, at the library, and also at the Acadia Sanctuary in East Hampton. And when I got to this slide at my East Hampton, at the Acadia presentation, I said on this map, and you'll see the big yellow area and the big white area, those are basically where we had no information. So we had some red spots. Berkshire County is mostly green because of limestone in the rocks. It's a strong neutralizer of acid. Excuse me. But huge areas of the state where we simply knew nothing. And I stood there in front of these 20 or 30 people and said, maybe we should do something about that. And suddenly the hands shot up like you could not believe. And everybody started asking questions. The questions went on for about 15 minutes. And I finally said, maybe we can hold the questions until the end. I can finish my presentation, and those who have to leave can leave, and we'll come back and we'll all sit down and we'll talk about what we might be able to do about this whole thing. Next slide. So we sat there, 20 or so of us, brainstorming what we could do. And as a result of the discussion, and I don't think any particular person deserves credit for coming up with the idea, it was a real joint project, we decided that some of us had access to laboratories and could measure pH and alkalinity. And I knew that those are the things we wanted to measure, pH being the predominant measure of acidity and alkalinity being the predominant measure of the environmental ability to neutralize that acidity. You can think of it as both ends of the pH scale. The pH scale goes from 0 to 14. 7 is neutral. That means basically if you have water, some of the water, H2O, dissociates into hydrogen and hydroxide, an OH, and the concentration of the hydrogen in the water is 1 over 6 zeros and a 1, with a decimal point in front of it all. so it's not very much. As the acidity increases, the pH goes down. As the acidity increases tenfold, the pH goes down 1 unit from 7 to 6. Conversely, if the alkalinity goes up, the pH rises by the same token. The acidity goes down by tenfold, the alkalinity goes up, and the pH will rise from 7 to 8. We're mostly talking about levels that are below 7 for any of the natural waters in Massachusetts and New England. In fact, somewhat closer to 6.5 or so for historical average as best we know it. So as a result of that meeting, we decided that some people had labs. We had 3 or 4 people who had access to a qualified laboratory where they could do pH on a pH meter with electrodes and do the titration for the alkalinity. The rest of the people were charged with collecting samples in Hampshire County along the Connecticut River area from approximately a little north of Amherst down to maybe Springfield. And all of the results from that, they would bring their samples to these laboratories. We would do it on a Sunday, what we came to know as Arm Sunday. They would bring it to their local laboratory. The local laboratory would then send a copy of all of this to me. These were in the days prior to emails and all of that good stuff. So it was put in the mail or phoned into me and accumulated on my desk. And it was not long, because I had involved volunteers in the project. It was not long before the media found out about it. And here's an article from June 2nd, 1983, probably the first article that came out in the Hampshire Gazette on the work that we were doing. And we started doing this every month, and interest grew, so that by the end of 1 month, or about 1 month, I was asked to do another presentation. If we could skip to the next slide. Let me just also indicate that the media was so good at this that I actually had someone come out and volunteer to raise money for our project. We had no money at all. They volunteered to help raise money for our project by conducting a concert, which was at the hangar in Hadley. Any of you have been to UMASS may remember it if you're old enough. It was a rock music venue, and I went, and in the intermission I gave a plea for money. We didn't raise any money, and when I could hear again, there was more and more interest on the part of people and others. As a result of all of this, I got asked to give a talk in Pittsfield to a group mostly of sportsmen, but anyone who wanted to come, and gave more or less the same talk about acid rain that I had given before. And again, all hands went up. What can we do? What can we do? And I answered questions to the group, and then afterwards people milled around and asked me even more questions. And a person came out of the audience and said, we need to take this statewide. That man was Leon Ogrodnik. You'll see his name on the left. And he said, I am connected in Trout Unlimited. Let's see if we can get some funds to support this. And I said, Leon, come to my office next week and we'll talk. He came. I wrote a proposal was for $20,000. We got the $20,000. The university, of course, takes a little piece of that. And we began to put together a network. Now, here's a key piece, 2 key pieces that we decided in that proposal that had kind of come out of that very early work that we brainstormed at the Arcadia Sanctuary. The first was that we needed to spread the effort among volunteers, using their capabilities as best we could. So Leon and I came up with this idea that we would have 13 county coordinators, and these were all people that he could trust to do the job. When he asked them to do something, they would get other people together and organize the various things that we had to do. Those 13 county coordinators would choose 4 to 6 local coordinators. The local coordinators would find volunteers to collect the samples. All of these people were invited, county by county, to come to a presentation that I gave. That's the first part. The second part was that we would not do this using simple, inexpensive, unreliable, low-quality techniques. We would try to achieve the highest quality data collection, data measurement that we possibly could. And so we needed as many labs, qualified labs, as possible. So one of the jobs of the county coordinators was to make contact with laboratories in their area. These could be hospitals, they could be county labs, they could be town laboratories, public health laboratories, or water labs. They could be colleges, universities, high schools, and so on, commercial labs. We ended up with 73 laboratories, some for-profit labs, others not. We had over 1,000 volunteers, and we had all of those coordinators that I mentioned. So that when I said we need to do something, word got to the county coordinators and then spread out to the local coordinators, or word went directly to the laboratories. The effort was spread out amongst everybody, and importantly, everybody felt a responsibility to the project. I had the task of going to every county and giving another one of these presentations. I was doing that 2 to 3 days a week for the period from roughly the end of January until the 1st of March. We collected our first samples around the 2nd week of March, the very first Arm Sunday. And we, sorry for the phone, and we continued to collect samples every month for a full year. As we were, let me find my place here. Next slide, please. I'm probably getting ahead of myself. Next slide. So as you can see, back up one, please. Not long after we started sampling in March, the press went absolutely crazy with this novel idea that we were using volunteers to collect scientifically acceptable data. Not everyone accepted the fact that it was scientifically acceptable, but the media was very interested, and so were our politicians and others. And as you can see, one of the politicians who became very interested in this was, at the time, Lieutenant Governor John Kerry and Representative Ed Markey and Ted Kennedy. Ted Kennedy and Ed Markey, both of whom had been helpful in trying to get our original EPA proposal funded. I was also invited to be on a committee with a number of notable folks that the Department of Environmental Quality Engineering, as the Department of Environmental Protection was known at the time, that was headed by Tony Cortese, to look at other research possibilities. The press was unbelievable. I had never experienced anything like that. I was a young, just got my PhD a few years before. I was not at all familiar with all of this kind of stuff, but I had to learn on the job, and I guess I did because it was successful. So let's go to the next slide. As you can see, it became truly crazy, and in the midst of this, I was trying to run this project and keep the level of quality as high as possible. uh, we were finding results. And just as a personal anecdote, I did not have a personal computer at the time. I had a pile of paper next to my desk, and the newspaper reporters were calling repeatedly saying, "What have you found? What have you found?" And I would look down at this pile and say, "I don't know yet. I haven't had a chance to look at it." Finally, I was forced to sit there and spend a day. I guess I told my secretary, "Don't let any phone calls come in," and sit there and tabulate the results. So if we could see the next slide. Next slide. I guess we're not going to see the results here. Nope, back up. But I was able to get some results out. We will see it in a bit. As the project progressed throughout the year, we were now into the summer, and along about June, I got, actually probably the end of May, I got a phone call from a state representative in the Gardner area, and he said, "We just put a funding provision in the state budget that would give you $50,000 to run this project. Is that okay?" When I could speak again, I said, "Certainly is." Now, we had started with people who we were using milk cartons and yogurt cups and anything we possibly could to collect samples. And we were using whatever pH electrodes and meters and titration apparatus was available in the various labs. And suddenly, with this $50,000, we were able to buy volunteers actual Nalgene bottles, 16-ounce bottles, to collect their samples in. And we were able to choose a pH electrode that we knew would be best for doing this kind of analysis, the most sensitive ones that we could find and the most reliable ones. And we were able to purchase those things. There was still no frills, but we were able to purchase those things for the volunteer laboratories and for the volunteers. And most importantly of all, I was able to hire someone to help me. And we had, at the time, Tom Zajac was doing the laboratory work and all of the quality control issues with the various volunteer labs that came up. He donated his time Sundays, usually on Arm Sunday, to solve problems that people were having with their pH meters. Now, what we did from very early on was to ask people to analyze a sample. It was unknown to them, but it was known to us. We sent it out prior to the sampling date, and they would analyze it. So they would report back to Tom Zajac, what their results were. He would then compare that with what he knew it should be and decide on whether they needed some help. And many of our laboratories did need help. That first March sampling indicated to us that many of them needed some help. Our volunteers collecting the samples did a fine job. Their job was a good deal easier. But the people working in the laboratories, most of them did not realize that pH meters are pretty delicate pieces of apparatus and require routine maintenance. And they didn't realize that they were not getting accurate measurements. They did when we finished with them because we knew what the true results should be. And that first month, we basically forgot the data, lost the data, because it wasn't very good. It was not up to my standards for our quality control. And the next month, however, we had solved all of those problems, and we had very good success with all of our analyses, meeting our standards that were the highest scientific standards that everybody was using. And so with the $50,000, we now could solve more of that problem by giving people the right electrodes to use. We also gave them something called a digital titrator. They were using these glass burettes. If you've been in a chemistry lab, you've no doubt seen one of these things. They're about 2 feet tall. And you fill it with, in this case, an alkaline solution that you then pour measured amounts into your water, and the pH changes, and when the pH gets to a certain point, it changes very rapidly. That's called an inflection point. And that inflection point, we measure how much alkalinity it took to get to that point, and then we know what the acidity of the water was. With a digital titrator, well, with the burettes, we had to assume that the people in each of these laboratories were properly mixing up the liquid that was in the burettes to do the titration. With a digital titrator, we could buy batches of the cartridges that went into them, and we knew they would all be the same. And we could test just how accurate they were in our laboratory and then know that the other laboratories were getting equally good results. So the $50,000 was absolutely critical to us. Silvio Conti, a representative from the western part of the state at the time, was liked the project so much that he actually put a record of it in the congressional record at that time. The next slide. In the next year, we weren't going to stop. We had done monthly analyses, but now we decided that we would try to expand that. And we expanded it in a number of ways. The first was that the initial funding had come from the state, but state funding has to go through one of the agencies. And at that time, I've already mentioned that not everybody believed we could get quality results with volunteers. DEQE, now DEP, declined to accept the funding because they didn't think we could do the job. They didn't think we would meet the quality standards that they have. Fisheries, Division of Fisheries and Wildlife at the time, said, we'll take the money. And it happened that a friend of mine was the chief fishery biologist for the state, and he became I didn't have anything to do with this, but he became the manager of the funds. In the second year, he came to my office and he said, we really love this project. What do we need to do a better job than we're doing? It's already good, but what can we do that's better? And I said, we need to do more chemical analyses of the water. We can't ask the volunteer labs to do more than pH and alkalinity, but we can bring samples back to a lab here at the university and do cation and anion analysis. That would be things like calcium and potassium, sulfate, chloride, so on, the whole suite. That was to be housed under Dr. Tom Zajak's supervision in the Department of Chemistry. We also asked for more money to support the laboratories, and if we could, and we created this laboratory for this sole purpose. We could have the next slide. Next slide. We also decided, back up one, we also decided that we didn't need to do monthly sampling, that we had already determined what the pattern was for the change over the seasons. We knew that the spring was the time when the pH was lowest in our lakes and streams, and we sampled approximately 2,000 of them in 1983 in phase 1. So we had a really good idea, better than anyone else had ever done for any particular state, of what that seasonal pattern was. And so we picked 4 times to sample the water bodies: spring, summer, fall, and winter. And we told our volunteers, we've sampled these 2,000, now let's sample all the rest. All the named and some unnamed lakes and streams and reservoirs in the state of Massachusetts. That's nearly 5,000. And that's what we did. We went out, all of the volunteers, we got more volunteers, volunteers got volunteers. We had families out there, we had old folks, we had young folks, everybody was sampling water. It wasn't a lot to ask of anybody. It was a very manageable thing, 4 times a year. Take a Sunday morning and go out and sample the water in water bodies that are near you, of interest to you, ones you see every day. And we had people out doing that sort of thing. They were so motivated. I got stories of people who crawled through culverts under the Mass Pike to get to a water body that couldn't be reached any other way. I had families going out and collecting samples. I had other folks. One fellow had just recovered from a heart attack, and he wouldn't be stopped. But one of the other volunteers said, "Well, if you insist on going out, I'll go with you." So that second volunteer sampled her own sites and went with him to sample his sites. It was that kind of thing that was really quite remarkable from the volunteers. Then when we went to phase 3, from 1985 to 1993, we sampled a smaller number yet. We picked a randomly stratified group. And for those of you who don't have a strong statistical background, that basically means that we covered all the areas in the state. We got lakes and streams in roughly equal numbers. We also sampled geological regions in roughly equal numbers. And because we knew the pH and alkalinity of all these water bodies by this time, we made sure that we had reasonable numbers in each one of those categories. That's what the stratification, the stratified means, is that we had enough samples from each of those various categories to be able to say something about each and every one of them. So in phase 3, we did that, and that ran from 1985 to 1993. If we could have the next slide. In that process, the press never let up. And so the awards didn't let up either. I was getting all kinds of awards. And I say I because it was always a little bit uncomfortable for me. I wasn't the person doing this. All of us were doing this effort. But somebody had to be the spokesperson, and I was the natural, I guess, for doing that. We got awards from some local places, and some national and some international ones. Some of the pictures that are shown here, the upper left is actually an international award from the United Nations for the project. In the center, you see George W. Bush shaking my hand, and down below, I hope you can see it, I can't, is the group of folks who received this international award from the United Nations, the Environmental Agency. And at the time, George Bush had been resisting the Clean Air Act of amendments of 1990. And it was only after work by Ed Muskie and George Mitchell and Ted Kennedy and others that it went through Congress, and finally George H.W. signed it. That picture was taken less than a week after he had signed the Clean Air Act amendments of 1990. So I felt like that the project that we'd started, that all of us had done, had really made a difference in getting those Clean Air Act amendments. But you'll notice down in that corner where all of the participants and receiving the environmental award is George Bush is there, and I'm there off to the right. The most important person for me was off to the left, and that's the folk singer whose name I have just forgotten, John Denver. He was there at this conference as well. Now, I mentioned Leon Ogrodnik's name, and he is shown in the picture on the upper right. He was an odd person. He did not want any credit for this, and yet he was instrumental in getting this to happen. It was basically his idea that we would use this through this structured way. Consider it a volunteer tree network that works so well. So as a result of all of this effort, the project was going along very swimmingly, and The funding was coming through, but little did I know that the funding that was coming to the Division of Fisheries was being used by the Division of Fisheries to get some federal money. The federal government had a program that would fund fisheries research in the state, and it was usually a fairly generous amount of money. But the state of Massachusetts did not have any fisheries research, so they never got any of that money. And when they saw the ARM project, they said, aha, this is our way. So they would take the state money that they got and give it to us, and then they would get reimbursed by the feds. And when the federal program changed so that that program did not only require research but included management, they said, oh, well, we don't need to do that anymore. We can get this money just on management for our hatcheries or whatever, and the project ceased to be funded. So it came as a shock. I said to all of the volunteers, carry on, you don't need me, you can do this, send all of the data anyway, I'll figure out some way to handle it. And I did manage to keep my staff on doing other things, but the volunteers really needed that central coordination. So we could have the next slide. In 2001, DEP, by this time, went to a conference of the New England Governors Conference, a side committee on the environment, and they were asked what their monitoring results were for acid rain. And in fact, all of the states were asked the same question. All of the states went through a long listing of what they had been measuring over the years. And Massachusetts DEP said, we don't have any since 1993, because the acid rain monitoring project was what they had. So I got a phone call a few days after that conference saying, can you start this again? And I said, I honestly don't know if I can or not. It's up to the volunteers. And I sent out an email and a mailing to all of the volunteers asking if they would be willing to collect samples and do the lab work as they had before. And I think the most heartwarming one I got was one from the southeastern part of Massachusetts. The county coordinators there said, ready to go, Chief. And I thought, oh my goodness, these people are really special. Next slide. And so we started up again in 2001. Throughout all of this, it was important to make sure that the volunteers understood what was happening, what their results really meant. Now, I didn't mention, and I meant to, that in 1986, the state of Massachusetts passed Clean Air Act that included strong acid rain control measures. This is 4 years before the nation, U.S., passed the Clean Air Act amendments of 1990 that helped reduce acid rain. So we were 4 years ahead of doing all of that. And the reason for it was because the volunteers were pressuring their legislature to reduce acid rain effects. They knew what the effect was. It wasn't Armageddon. The end of the world wasn't coming, nor was it caused by natural things. It was concerning. They could see that a large number of water bodies were very sensitive. Some of them were becoming acidified. They were the ones collecting the information. It was theirs. And the way we did that was we produced a number of booklets. That one in the middle was probably the most important one of all. The two on the side are sort of scientific research publications that could have been published in a journal, but instead were published in the Water Resources Center's publication series. The one in the middle was intended for everybody, for schools, for everybody to be able to read and understand. And you'll see that map. There's that map again, but this time it's all filled in. There are no areas of no sensitivity, no data. It's all filled in. I think there's one place where there may not be any water bodies there. but everywhere else is all filled in. The next slide. So now we get to see some actual results. And because we have data from 1983 to now, with a few years off when funding was at present, this is a 37-year record. And I have to report that because of the pandemic, we were not able to sample this April. It's the first April we haven't sampled when we might have. We had plans. It was all in the works, but it was canceled at the last minute. But let me just show you some of the data that we have. So what we see from this is that we've broken this down into our pH values, and pH is a measure of the acidity of the water, and the ANC, that's acid neutralizing capacity or alkalinity. And we see that for the pH going up, that means they are less acid. 30% of the water bodies have gone up in pH, becoming less acid, and the acid neutralizing capacity has gone up as well. So what we're seeing is the recovery based on the pollution reductions that occurred as a result of the Massachusetts Clean Air Act and the later National Clean Air Act amendments, 1986 and 1990 respectively, so that by now we're seeing change. Some asked me, well, has the change been dramatic? And I said, no, nothing in the environment tends to be dramatic. This is going to take a while. It took us over 100 years from the start of the Industrial Revolution to get to where we were in 1980. And it's going to take us some time to get back to a natural situation later on. But you can see that for lakes and ponds and all sites, the improvement has been, I would say now, quite dramatic. Our lakes and streams are coming back. One of our concerns was Quabbin Reservoir. It was the original reason that I got involved in acid rain research. And it had an alkalinity that was down around 2 milligrams per liter. The reservoir was very, very close to becoming acidified. It would have had to be treated with a buffering compound to reduce acid water going into the pipes to Boston and so on, where we knew there were lead pipes, and the lead would have leached out of those pipes and into young children. We did not want that to happen. And Quabbin Reservoir has improved over time, as have all of these others. Now, I can't see them very well, but below that is the result of our cation and anion analysis. There are a couple of things I want to point out here. The original Clean Air Act, both of the Massachusetts and the US one, focused almost exclusively on reducing sulfuric acid, H2SO4. And you'll see that in that lower chart, the sulfate values have gone way down in the surface waters of the state. The other component of acid rain is nitric acid. It's about a third of the acidity because sulfuric acid has 2 hydrogen ions and nitric acid only has 1. It's about a third of the acidity that comes in our rain. The source of the sulfuric acid is largely electric power and other industrial power generation. The source of the nitric acid is largely the result of transportation sources, i.e. your car and the trucks and so on. The Clean Air Act amendments did not do very much about transportation sources, so we see an increase in the nitrate levels in our surface waters over time as a result of more cars on the road than ever before. So there are those two factors. There's one other one that's a curiosity to me, and maybe to you as well, and that is that the color in our water bodies has changed. And this needs a bit of an explanation. Color in water bodies, it represents organic acid in our waters. Many of you may have experienced brown lakes and streams. I remember when I worked on my master's degree, I was on the Miller's River system, and we had a fairly significant stream that came into the Miller's River called Priest Brook. And it was tea-colored, a very strong tea color. And that was all from organic acids, from the leaves of trees, pine trees and oak trees and so on, breaking down and forming organic acids and coloring the water brown. This is more of a characteristic of lakes and streams in the eastern part of the state than it is in your area in the western part. But what we saw with acid rain was that the color for a number of years was diminishing. The reason for that is that the organic acids, and here I just said the word acid, but the organic acids were acting as a buffer, neutralizing inorganic acids, the sulfuric acid and the nitric acid that were coming in acid rain. So in effect, it wasn't much, but it was some small protection for those tea-colored waters. But as time went on, the acid coming in exhausted the organic acids. And what we saw was that the waters lost their color. We had volunteers reporting, when I started sampling this, the water was brown. Now it's not brown anymore. And then 10 years later, we had volunteers saying, my waters used to be clear, and now they're getting brown again, just as they used to be. What's going on? What's going on is that the acidity, the mineral acidity, sulfuric acid and nitric acid, is being reduced and replaced with that natural acidity from the breakdown of organic products in the watershed. The pH from organic acids will not get to the point where it endangers the life of fish or other life. And the waters will turn back to what they were naturally over time. The other thing that one of my staff people and I focused on was chloride levels. We hypothesized that the level of chloride and also sodium was related to transportation, road salt. Sodium chloride, road salt. So we looked at the correlation between road miles and the type of road miles in the watersheds of all of the water bodies that we sampled. And what we found was a very strong correlation between our turnpikes and our highways and the sodium and chloride levels in the lakes and streams that were impacted by those roads. So if 5 miles of the Mass Pike went through the watershed of a particular water body, we would see that the sodium and chloride levels were going up over time. This was less true for town roads and for city streets and so on, simply because they tend to get less salt than the major highways do. So there was a very strong indictment of road salt for changing the water quality of our surface waters. Next slide. Because of the impact that those volunteers had had on our surface waters, we knew that lots of help could be provided. And I want to tell you a little anecdote. I was asked to give a presentation at the American Chemical Society back in the 90s, and I went and I gave that presentation. And as I came out of the meeting, I was getting into the elevator. The director of EPA got in the elevator with me. And he spent the next 5 minutes yelling at me saying that you can't do that with volunteers. And I sat there and accepted it and said, yes, I can, and I'd be happy to show you that I can. Of course, I just had in my presentation, but he wouldn't accept that fact. He finally got out of the elevator and went off, and I had always offered EPA all of our information. And at one point, about 2000 or so, I got a phone call from an office in EPA that was putting together a regional map of various things, and they were interested in our data. They had gone to the state labs, and this is Lawrence Laboratory, and asked for some data, pH alkalinity and phosphorus being a measure of the level of eutrophication and nutrient enrichment of the water body. And they were putting together maps of all of these things, regional maps, pretty colored things. And they wanted to have some of the data. And they put all of this together. Now they had all 6 New England states. And when they looked at the map, they realized that the Massachusetts data just didn't fit. It was like a round peg in a square hole. All the other states were consistent with what they knew about the geology of the area and so on, but not Massachusetts data. So they went back to the lab and said, could you share with us your quality control data? And the result was that the lab said, well, we really don't have any. And, well, what methods did you use? Well, sometimes we use this method, sometimes we use that method. And so EPA abandoned using the Massachusetts data. That's when I got the phone call. They said, do you have any of these data? I said, certainly do. Would you share it with us? I certainly will. I sent them the data, and about 6 months later, I got a note back, just a discrete note given their history, that said, we've decided to use your data from the acid rain monitoring project. We have found that the data quality are equal to ours. This is EPA talking. What they were really saying was perhaps even better, but I felt vindicated from my little event in the elevator that EPA had finally accepted the data. Of course, the state had long before accepted it, and the region and so on. One other little story, and that is after the first year of our sampling, I was invited to come down to a national conference of volunteers held in Rhode Island. And most of the people there were talking about beach cleanups and things of that sort. And I talked about the acid rain monitoring project, and of my 15 minutes or so, I probably spent 10 minutes talking about the quality control program. And no one else had mentioned quality control. Most people had never heard the term before, and they were some chemistry and lots of things on cleaning up water bodies, a number of them working on acid rain using litmus papers and things like that. So there was sort of a silence when I spent all this time on quality control. The next year I was invited back, was also at Rhode Island. And this time I decided not to talk so much about quality control. I had a lot more results to present. So I spent my time talking about all of our results, a little bit of time on quality control. But everyone else talked about their quality control program. And I thought, aha, it worked. They're all beginning to pay attention to this most important aspect of doing volunteer work. And that segues into a second effort at using volunteers. The lakes, and I had mentioned this eutrophication problem, nutrient enrichment of lakes, which causes either algae or weeds to grow in the lake. And there were a number of watershed associations that were very concerned about changes going on in their lakes. And there is a statewide organization called the Congress of Lakes and Ponds, COLAP, that tries to organize all of these various lake associations into one whole and have some political impact as well. That organization was not very strong. It had gotten weaker. People really didn't know what to do about lakes. Lake associations were often hiring consultants to come in and advise them. They didn't know whether the consultant was giving them the honest truth or not. They were all expensive solutions. They wanted to find out for themselves what was going on. They also wanted to be able to go to their DEP regional offices and have ideas presented and good ideas accepted for possible funding, or at least not the agency wouldn't stand in the way of doing some sort of management. So we worked with the folks at COLAP and also with folks within the Executive Office of Environmental Affairs to see if we couldn't help those volunteers to learn more about their lakes. And we set up a training program. We were not going to collect their data and keep it in some central repository, but we were going to help them do quality work that they could trust, and to help them understand how lakes worked. So we set up a variety of training, guidance, quality control programs, also educational programs so that they could do all of these things. And you see some of our volunteers collecting samples. They were collecting in the upper left corner, they were doing Secchi disc transparency. That's a measure of how far down in the water you can see a black and white cylinder. And that tells us a great deal about the algae in a water body. And folks, the fellow on the right is actually doing a filtration to make a chlorophyll measurement, another more accurate measurement of chlorophyll. And then in the lower left, they're doing, with one of our digital titrators, doing pH and alkalinity. And then some folks are collecting stream insects. And we taught them how to do good jobs with all of these things. If we go to the next slide. Next slide. You'll see more of our training. These were often done in nice venues. The side, back up, I've got a series of these we can look at. They were often done lakeside on nice days. It was always rather nice. We've got somebody from, in the upper left, we have somebody from the Department of Environmental Protection and one of my staff people, Jerry Shane. We have folks from DEP in the next to the right of that, and my staff assistant for the ARM project was also working on what we call Massachusetts Water Watch Partnership in the center. And down in the lower right, we have folks from the USGS doing training sessions for the Water Watch Partnership. Next slide. And we were showing them how to do things that limnologists do, and presenting all of this to the results to them and to others so that they would understand what needed to be done. The next slide. Next slide. We back up. We retasked our environmental laboratory to help out with the Water Watch Partnership, and we showed many of them how to do the techniques that they needed to do for themselves, so they wouldn't have to rely on our lab or have to pay other labs to do this. Next slide. Part of our way of saving them money was to design equipment to substitute for much more expensive equipment. That little mason jar on the right-hand side of your screen, that's called a Wisconsin sampler. I first saw the design for this in some publication from a water center publication from Wisconsin, I think, and adapted it for our use. It's a mason jar with cement in the bottom, so when it's closed, it will sink. The cement is sealed off from the water that will fill the upper part with epoxy. There are two Bic sticks. Those are the pens, the very inexpensive Bic pens. We take the point and the ink cartridge out of the inside. We'd save the caps, and we would insert them into the lid for mason jar, one of the Bic sticks going down to near the bottom, near the cement level, one of them being up at the top. So when it was lowered in the water would go in one tube and the air would come out of the other tube. And we seal that so that with the little caps that you see with the strings attached, so that we could take a bottom sample. it was easy to take a surface sample. You use the principles of the acid rain monitoring project. Take a bottle, stick it in up to your elbow, and turn the mouth of the bottle up so that it would fill with water. But how do you get a sample from the bottom of, let's say, a 35-foot lake? Well, you can buy a couple $100 instrument called a Van Doorn bottle, or a couple of other kinds of things that most of our volunteers really didn't have that kind of money to spend on the equipment. So I came up with this thing for $3.25, I think it cost me to make these. And I made them, and we more or less gave them to volunteers. One would lower this down. The caps were placed into the big sticks, and the weight of the bottle was hanging from the upper hook in this line affair. And when it got down to the proper depth, you would give it a little yank and it would pull the caps out. The bottle would now hang from the lower clip and fill with water. And then when it filled with water, you'd watch the bubbles come up to the surface. And when the bubbles stopped, you'd pull up the sample, and you had a sample from the bottom or anywhere else below the surface that you wanted. We also made the Secchi discs. One of my staff people, Mark Matson, who has been working with DEP for quite some time now, bought a 4x8 sheet of plywood, and we cut it up into circles, and we painted it, and we made Secchi discs. Another $3 thing. These normally cost $85 if you buy them from Biological Supply House. And finally, two more items that we saw in pictures earlier. The tall white plastic things are viewers, transparency viewers. If you lower the Secchi disc from the bottom part down in the water, if it's a cloudy day or the sun is really strong and at an angle, you can't see very far down into the water. So the way to get around that is to use a tube like this one in the back that you could stick in the water, and it would cut the glare down, and you could accurately see to the depth that you were measuring the transparency. And the depth is when you drop this thing down in the water, when you can't see it anymore, you note the depth with a marked line, and then you bring it up till you can see it again. You take the average of the two, and that's the Secchi disc transparency. We made those things for the volunteers, a buck or two for those. You can buy them for $50 or so. The other technique was a chlorophyll technique. This was one where we could buy fairly inexpensive equipment so that people could collect a sample and filter it on a glass fiber filter, and then that filter could be brought to a laboratory. But bringing it to the laboratory is the hitch, because the sample has to stay either fresh or frozen until it gets to the laboratory and is analyzed. For most people who were not close to a laboratory that could do chlorophyll, and there aren't that many in the state, that meant putting it in a styrofoam cooler with dry ice and mailing it, and that's expensive. So I developed this technique called air drying. We discovered at some point that if you air dried a sample, got it really dry, the chlorophyll on it would last for a very long time. So I came up with a little fan and a container and a thing to put the filter on and hold the filter down. You can put the filter there, run this dryer for maybe 15 or 20 minutes, then put the filter in a piece of paper and a normal envelope with a forever stamp on it and mail it to our lab, and we could do the chlorophyll. And I knew that the chlorophyll would not change for several months after it had been air dried this way. Those were probably $20. So that would be the cost of shipping one chlorophyll sample to a laboratory, probably, or maybe even less than the shipping cost. And so we did all of these things to save this for volunteers. As a result of all of this going on, COLAP was reinvigorated. People now, many, many more lake watersheds were coming to the COLAP meetings. Another thing developed because the state was beginning to believe that we really knew what we were doing when it came to quality control. I was asked to write a book on volunteer monitoring, guidebook to quality control. And that has been the mainstay for state interaction with volunteer groups. They basically say, follow these procedures, all will be well. And then also, lake management's a really tricky business. There are a lot of options, most of them expensive. Consultants are available, but you need to know whether the consultant's on track. They're not as familiar with your lake as you are. And we were finding that there were differences of opinion between consultants and mostly between regional state agencies. So the DEP office in Springfield might not agree with what the DEP office in Worcester did. Some things would get approved in Worcester and not be approved in Springfield and so on. So there needed to be some standardization of what everybody understood. So I was asked to put together a committee, and we had on it all of the state agencies, the conservation commissions, the environmental consultants, a number of lake watershed associations, and so on, to come up with procedures that could be followed and a general manual for understanding our lakes and streams. And a staff person and I worked on this. It happened that after we had the first draft and it was in the state review process, I retired, so the final draft was done by one of the consultants, but it's changed very little from what it was. Now, I think that the message that comes out of all of this is that not so much a lesson about acid rain, which is kind of old history now. We've more or less solved that problem. It's a lesson of how to use volunteers and what volunteers provide and the important parts of that. I've mentioned the empowerment of the volunteers. They need to learn what has to be known. They need the facts, and they need to feel like they have some control over those facts. Quality control is a big part of that. If people are doing things that they know are accurate, then they have faith in the results and out on a limb and use those results to make a point. We did all that with ARM, but it can be done with other volunteer efforts as well. Also back in '83, none of the state and federal agencies, or almost none of them, accepted anything from volunteers except, rants. They didn't believe any of the results. That's not true anymore. Nowadays, in Massachusetts, I know for sure, and in many other states, volunteers play a critical part in environmental monitoring to meet state needs. The environmental agencies within the state rely on volunteer organizations to do a lot of the work for themselves. And we help to pull that together by creating this book on the next slide. I guess 2 slides. Could show the next slide. This is more. Let's skip to the next slide. Quality assurance for volunteers. Many of the state agencies use that too. They discovered we were doing it very well. And this is the generic environmental impact report that gave guidance to lake management groups of all kinds, consultants, lake associations, and so on. And the next slide. That's still in use, by the way. 15 years later, it hasn't its utility has not changed. And you got to have a little fun once in a while. And next slide. Next. This is the shared waters. Back up one if you can. Where we got all of the New England agencies together and the model for acid rain monitoring that we had used and for the Water Watch partnership that we had used in the state. Many of the other states in New England and New York took those things to heart and have greatly enhanced their overall environmental efforts by using volunteers and using the procedures or slight modifications of it that we'd helped to develop in the 80s, 90s, and even now. And with that, I will stop. I know I ran over my time. Sorry about that. I hope it didn't inconvenience anyone. But if you have any questions, I'd be happy to answer them. And I guess I push my little box here.
Thank you very much, Paul. So I will open up the chat box, and there's not an overwhelming number of people, and so I would also say that I would invite anyone to either type in a question in the chat box or feel free just wait for a pause and then just speak your question if you have one, and maybe I'll just throw one out. Paul, I'm wondering the sort of inspiring work that you did with volunteers in Massachusetts. Were there other states outside of Massachusetts that followed the example that you set here? Yeah.
There were some that there was one that was actually a little bit ahead of us. That was in New Hampshire for lakes only, and it did include some acid rain stuff, but it was mostly for lake management procedures. Maine, pretty much, they had a monitoring program, but it was largely done by their own state folks. There was one, I'm trying to remember, Kentucky had a pretty good one. And we worked with them. They had one when we started. When I made that first presentation in Rhode Island, Kentucky was another one, but they hadn't focused as much on quality control as they should have, and they came back strong with excellent quality control program in the years after that. A number of other states got started after the acid rain monitoring project, saying, aha, this is how we can do these kinds of things.
Thank you. I see that we have one message perhaps in process. Well, maybe not. So, last options here. Yeah, go ahead, Dan.
Could I ask a question?
Please.
Sure. So do you think there's some natural limits in using the public for data collection? Like what's like kind of natural thresholds where it's just kind of going too far with what we might expect kind of a lay public to be able to contribute to scientific endeavors?
Well, I guess that question has two sides to it. One is that you don't want to load them up with so much work that they feel they have busy lives, and they're more than happy to take a little bit of it and give it towards a particular effort, but they're not going to give up their whole lives or careers or anything else to a particular effort such as acid rain monitoring. So we did that. We asked them to do what they felt they could handle. If you can do one site, please do one site. If you could do 6, great, do 6. The labs probably took it on the chin a lot harder because they didn't have control over how many samples showed up, but they also didn't have to go out in January and collect samples. They could work from the warmth of a lab, and they usually were able to finish their analyses in a few hours. So we never asked them to make a huge contribution of time or effort. I think the other side is, are there things that are too difficult for volunteers? And I think that question bears on what we do about climate change, what we do about pandemics. Those are bigger issues with much more difficult questions to ask. And yet I still think, and it's not for me to do this, another generation can come along and figure it out. But I do think that volunteers will play a very strong role in how we solve both of those problems. I hope that answers your question.
Yeah, thank you.
I think just on that subject of climate change, if we're going to change the climate in the direction we want it to go, it's going to be on the part of everyone. It's not just going to be some decision on high that says that it shall happen. It will be our changing our way of life to some degree, or doing things differently, maybe not in a more inconvenient way, but just differently, and being more aware. And it's that kind of message that I think came out of the acid rain monitoring project, that people were eager to learn more and to do the right thing for the most part, if you just help them to learn what that is. For the pandemic, again, we slow this thing, we stop it eventually by everybody playing a part. And the more each of us personally understands about the difficulty of doing it, what needs to be done, the easier it will be to get to that point.
And on that note, I think I'd like to thank you very much to our speaker, Paul Godfrey. Thanks very much for taking the time to share this story with us. And thanks to all for participating and for the good questions. And we'll end there. Thank you.
Thank you.
Thanks, Paul. Thanks, Elena.
Thanks, Dan.